All right, so let's talk about a really big idea in math called the derivative. Now, that word might sound a little intimidating, but the core idea is actually something you already understand. It's all about figuring out how fast something is changing at one single specific moment. So, to get a feel for this, let's imagine a little story. I'm going to draw the ground here, just a simple flat line. There we go. And let's say you're standing here and you take a ball and you throw it straight up into the air. What happens? Well, the ball goes up and up and up. It slows down until it reaches its highest point, and then it starts to fall back down faster and faster until it hits the ground. So the path looks something like this, a nice little arc. Now, here's the question. Is the ball moving at the same speed the entire time? No, right? Of course not. It's moving really fast right when it leaves your hand, then it slows down as it goes up. It actually stops for a split second at the very top, and then it speeds up again on its way down. The speed is constantly changing. Okay, so let's clear this drawing away for a second. Let's get rid of the ground and the path. Perfect. Now, let's try to look at this in a more mathematical way. Let's draw a graph. I'll make a vertical axis here. This will represent the ball's height. And I'll draw a horizontal axis, just like this, and this will represent time. So when we start the clock at time 0, the ball is at some height. Let's say in your hand, right here. I'll put a dot. As time moves forward, what happens to the height? Well, it goes up and up and up. It reaches a maximum height. And then, as time keeps going, the height starts to come back down until it eventually hits the ground at height 0. So the graph of its height over time looks a lot like that arc we just drew, doesn't it? See this curve? This tells the whole story of the ball's flight. Now, here is the big question. How fast is the ball moving at any one specific instant? For example, let's pick a point in time, say right here. I'll put a dot on our curve. At this exact moment, what is the ball's speed? This is the question that derivatives help us answer. And the way we do it is actually pretty neat. We look at how steep the graph is at that exact point. To measure the steepness, we can imagine laying a ruler down on the graph so that it just barely kisses the curve at that one single point. Let me try to draw that line. It just touches the point and keeps going in both directions, just like that. Perfect. This line has a name. It's called a tangent line. And the slope of this line, how steep it is, tells us the speed of the ball at that exact moment. See how this line is pretty steep and going upwards? That means the ball is moving upwards pretty fast right there. Okay, great. Now, what if we look at a different moment? Let's pick a point higher up on the curve, closer to the top. Say right here. I'll put another dot. Let's draw the tangent line here. Let me sketch it. It just touches at that point. There we go. Now look at this new line. Is it as steep as the first one? No, it's much flatter. The slope is smaller. And that makes perfect sense, right? We know the ball is slowing down as it approaches the top. So what about at the very peak, the highest point of the whole trip? Let's put a dot right at the very top. If we draw a tangent line here, what does it look like? It's a perfectly flat horizontal line. And what's the slope of a flat line? It's 0. The slope is 0. And that's exactly what's happening to the ball. For just one instant at the very top, its speed is 0 before it starts to fall. See how this works? Let's do one more. Let's pick a point on the way down. How about right here? I'll draw the tangent line. It touches the curve right at our dot. Okay, look at this line. It's steep again, but this time it's pointing downwards. It has a negative slope. And that tells us the ball is moving fast again, but in the downward direction. So this whole idea, this process of finding the slope of the curve at any single point, is what we call finding the derivative. That's all it is. A derivative is just a measure of an instantaneous rate of change. It tells you the steepness of a graph at a single point. So when you hear that word, derivative, just think slope. How fast is something changing right now? Pretty cool, huh?